Today, something truly extraordinary happened in our solar system. The Sun, our closest star and the powerhouse of life on Earth, just erupted with the most powerful solar flare we've seen in over 7 years. And the effects? Well, they're about to be felt right here on our planet. Buckle up, because we're going to break down exactly what this means for all of us and how a massive solar flare could impact life on Earth. First, let's talk about what exactly happened. At 8:10 a.m. Eastern Time, a colossal solar flare erupted from a particularly active region of the Sun called sunspot group AR3842. Now, this isn't the first time this sunspot group has caught our attention. Just 2 days ago, it fired off another powerful flare, an X7.1 class solar flare, which is already on its way toward Earth. And now it has outdone itself with an even bigger flare, a monstrous X9.05 flare, the most powerful eruption of this current solar cycle. So, what does X9.05 actually mean? Solar flares are classified by their intensity, and the classification system is pretty straightforward. The smallest flares are classified as A class, followed by B, C, M, and then X class at the top. Each letter represents a 10-fold increase in strength. So an M-class flare is 10 times more powerful than a C-class, and an X-class flare is 10 times more powerful than an M-class. And then, within the X-class itself, we use numbers to specify just how intense it is. So an X9.05 flare, like the one we just saw, is one of the strongest solar flares we can experience. To put it into perspective, the last time we saw flares this powerful was back in 2017. That year, 2 massive solar flares were recorded, an X11.8 and an even stronger X13.3. These flares were so powerful that they disrupted satellite communications and caused widespread auroras. But it's important to remember that solar activity like this follows an 11-year cycle, known as the solar cycle. We're currently in solar cycle 25, and activity is ramping up as we approach the peak of this cycle. This is why we've been seeing so many more solar flares recently, and why scientists have been keeping such a close eye on the sunspot activity. But here's where things get really interesting. When a flare like this erupts, it can sometimes trigger what's called a coronal mass ejection, or CME. CMEs are enormous clouds of charged particles that are hurled into space alongside the flare. And if a CME is directed toward Earth, it can have some profound effects on our planet's magnetic field. So, what does that mean for us? Well, preliminary data suggests that today's massive X9.05 solar flare likely did unleash a CME, and the good news is, it appears to be Earth-directed. If this CME does indeed make contact with Earth's magnetosphere, we could be in for a spectacular show. You've probably heard of the northern and southern lights, or auroras, but what you might not know is that they are directly related to solar activity. When charged particles from the Sun collide with Earth's magnetic field, they interact with gases in our atmosphere, releasing energy in the form of light. The result? Those breathtaking auroral displays we associate with the polar regions. Now, thanks to this solar flare, we could see auroras much further from the poles than usual. The incoming CME is expected to hit Earth between October 3rd and October 5th, and depending on how intense the impact is, auroras could be visible in places much further south than normal. So if you've ever dreamed of seeing the northern lights, this could be your chance. Keep an eye on the sky in the coming days, especially if you live in higher latitudes, and consider using an aurora forecasting app to check your chances. However, while the prospect of stunning auroras is exciting, we can't ignore the potential downsides of a solar storm. When CMEs collide with Earth's magnetosphere, they can cause geomagnetic storms. These storms, depending on their intensity, can have a wide range of effects. At the milder end of the spectrum, you might experience some issues with GPS systems and satellite communications. After all, the particles from a CME can interfere with the signals that these systems rely on. But in more severe cases, geomagnetic storms can cause problems for power grids and even disrupt air travel by affecting high-frequency radio communication. In fact, we've already seen some effects from this morning's X9.05 flare. Shortly after the flare peaked, there were reports of shortwave radio blackouts over Europe and Africa. These blackouts happen because the radiation from the flare ionizes the Earth's upper atmosphere, creating a denser environment for radio waves to travel through. As these radio waves pass through the ionized layers, they lose energy due to increased collisions with electrons, which can weaken or even entirely absorb the signals. This is why radio operators in the sunlit parts of the Earth were likely experiencing issues in the immediate aftermath of the flare. But here's the key takeaway. Solar flares and CMEs are unpredictable, and space weather can change rapidly. Scientists are constantly monitoring the situation and updating their models to predict when and where the CME will strike. So while we know there's a strong chance that the CME will hit Earth, and we know that geomagnetic storms could follow, the intensity of those storms remains uncertain. It's possible that the effects will be mild, with only minimal disruptions to satellites and power grids. But if the storm is more intense, we could see more significant impacts. Either way, it's a reminder that we are living on a planet that's constantly being affected by the cosmic forces of our solar system. This brings us to a larger point about solar activity and its implications for modern society. As we become increasingly reliant on technology, satellites, GPS, power grids, communication systems, our vulnerability to space weather increases. Events like the one we're witnessing today remind us that space isn't just something that exists out there in the distant universe. The sun and the massive amounts of energy it releases has a direct and sometimes dramatic impact on our planet. Let's not forget the Carrington event of 1859, the most powerful geomagnetic storm on record. Back then, a massive CME caused widespread auroras that were visible as far south as the Caribbean. Telegraph systems, which were the height of technology at the time, went haywire. Operators reported sparks flying from their equipment, and some telegraph lines even caught fire. Fortunately, modern infrastructure is better prepared for these kinds of events, but we are far more dependent on technology than we were in the 19th century. A storm of that magnitude today could potentially cause widespread power outages, disrupt global communication networks, and cost billions in damages. It's a sobering thought and one that drives ongoing research into how we can better protect our infrastructure from the sun's occasional outbursts. So, what's next? Right now, we're in a bit of a waiting game. Over the next 24 to 48 hours, scientists will be closely monitoring the incoming CME to see how it interacts with Earth's magnetic field. If conditions are right, we could see widespread auroras lighting up the night sky in areas that don't normally get to experience them. If you live in the northern United States, parts of Canada, or northern Europe, be on the lookout. You might just get to witness a natural light show. And even if you're not in a location where auroras are visible, it's still worth following space weather updates to see how this event unfolds. The sun is entering an increasingly active phase, and this flare is unlikely to be the last significant event of this solar cycle. Finally, for those of you who are space enthusiasts or just curious about the science behind all this, there are plenty of resources available to track space weather in real time. Apps like My Aurora Forecast and Alerts or Space Weather Live can give you updates based on your location and help you determine when and where to catch a glimpse of the northern lights. And even if you don't get the chance to see auroras with your own eyes, following these apps can provide a deeper understanding of how space weather impacts our daily lives. In summary, the sun just unleashed a solar flare of massive proportions, an X 9.05 flare, to be precise. And while the beauty of auroras may be on the horizon, there are also potential challenges ahead, from radio blackouts to possible disruptions to our technology. As we await further data on the incoming CME, one thing is certain: space weather is a reminder of the powerful forces at play in our solar system, and the sun, in all its fiery glory, remains a constant source of both awe and respect. Stay tuned as we continue to track the effects of this solar storm, and remember to keep looking up. You never know when the universe will put on a show.